27, for the given graph, write in terms first of sine and then cosine in standard form. Write the function in terms of sine of y equals sine of x. So a few things we can do, but identify the amplitude here first. So we get a low of -1 and a high of 5. So 5 minus -1 is 6. So that's the total distance from top to bottom. 6 divided by 2 will equal the magnitude of our A, which should be 3. Then we're going to look at shifting vertically. So we can see that it has been shifted up 2 units because the midpoint, and that's where the midpoint is. So that'd be our K value is 2. Next we can go on to our B value, which we can look here, start at 0, and we end at 20 pi. So our B will be 2 pi divided by that trough to trough, which is 20 pi. Pi's cancel out. 2 divided by 20 is 1/10. And then we need to figure out our horizontal shift, if any. So normally we'd assume sine to start at the midpoint, so we can see that there is a shift here. See that that's halfway between our 0 and our 10 pi. So our H will be a shift of 5 pi. Then we need to determine, we know the magnitude of our amplitude, but we need to determine if it's been flipped. So if we shift over by 5 pi, we would get the typical sine wave that we had come to expect. And with that, we know that since it starts going up, it will not be flipped. So now we should have enough information to say y is equal to the amplitude being 3, sine our B value of 1/10, x minus our horizontal shift, close that all up, plus our vertical shift of 2. So now we can look at what the cosine will be, and there's some values that we can keep from the cosine. So the cosine values that we can keep, the magnitude of the amplitude we can keep. Our horizontal shift might change. Our B value will stay the same, or sorry, our K value will also stay the same. Here's our horizontal shift down here. So between those 3, all we need to figure out is the sign, meaning positive or negative, of our amplitude and our horizontal shift. So cosine, we expect to start at a maximum, but here we start at a minimum. So that's really nice. It means that our H is 0, so there's no horizontal shift. But from that, since we started at a minimum, we know that our amplitude will be negative. So we should be able to say y equals -3 from our amplitude. Cosine 1/10, because the period hasn't changed, x minus 0, close that off, and our vertical shift hasn't shifted. We can then simplify this just a little bit to clean it up. One summer day, the high temperature was 103 and the low temperature was 69 Fahrenheit. The temperature throughout the day can be modeled by a sine or a cosine graph, where T represents the hours after 3 a.m. Find each of the following. We'll use a sine or cosine. I'm seeing that we hit a minimum here, or at time equals 0. So I'm going to use a cosine. Most likely be the easiest one. So the horizontal shift, because we started at that minimum, will be 0. Our amplitude is half the difference here. So we'll get 34 divided by 2 is equal to the magnitude of the amplitude, which would be 17, or magnitude of A, which is 17. So 17, but we know that it should be a negative 17 for the value of A, given that we started at a minimum and we're using a cosine function. Period. We can measure that from trough to trough, whatever those x values are, and that's 24 hours, which is in line with what we'd expect a day to be. But then B is equal to 2 pi over 24, which simplifies to pi over 12. The midline, you can take either the minimum and add the amplitude, or you can take the maximum and subtract the amplitude. I'll do the 69 plus 17, and that should come out to 86. So that means our K value is also this 86. So it says write your answer in the form of f of x for the sine or g of x. So g of x equals negative 17 cosine of pi over 12 x plus 86. For those of you who chose to do sine, things will be very similar. Your amplitude is still 17. Your value of A will be a positive 17. Your B will be the same. Your midline will be the same. You will have a horizontal shift of 6 hours. So we'd represent that by a shift, and the equation will be a positive 17 sine of pi over 12 x minus 6 plus 86. A company's sales are seasonal with a peak in mid-December to equal 0 and the lowest sales in mid-June to equal 6. The trigonometric function represents the sales in thousands of dollars at T months after mid-December. What are the highest and lowest sales amounts? So we'll plug in 2 cosine. We'll plug in 0 because we were told that that is the highest time plus 68.7. And with that, we'll see that's cosine plus 68.7. We'll see that's cosine of 0. So we could plug that into the calculator, or we should recognize that that's a special value of cosine. And we'll get that cosine of 0 is equal to positive 1. So it'll be 43.2 plus 68.7, and this should equal 111.9, and that is in thousands of dollars. And then we are also told that we have the lowest sales at t equals 6. So again, 43.2 cosine of pi over 6 times 6 plus 68.7. We'll simplify inside that cosine to be cosine of pi. And again, we could put this into our calculator, but we should also be able to recognize that this is a special value of the cosine function and gives us -1. So it'll be minus 43.2 plus the 68.7, and we should get that that is 25.5, again in thousands of dollars. All right, find a possible formula for the trigonomic function with a minimum value of 0 and a maximum at 3 pi over 8, comma 5. Write your answer in the form of those. Notice that there is no horizontal shifting. So it looks like we also have a point here at 0, 0, which does correspond with a minimum value of 0. So we'll go for the amplitude first, which will be 5 minus 0 divided by 2, which would be 2.5. Our k value will be either a minimum or a maximum, and we'd either subtract or add the amplitude. I'll do the 0 plus our amplitude, or the minimum. So I get that that's 2.5. Our b, so we need to figure out what the period is. So here we're at the 3 pi over 8. That's the half period. So the full period would be 6 pi over 8. So our b will be 2 pi divided by 6 pi over 8. 2 pi over 1 times 8. 6 pi. Pi's will cancel out. That will reduce down to 3. So we get 8/3 for our b value. So now we have enough information that we can use the cosine with. Just because we figured this out, this was the magnitude of the amplitude. Since we started at minimum, it'll be a negative value. It's a negative 2.5 cosine of 8/3 x plus 2.5. All right, determine the amplitude, period, phase shift, and or vertical shift of the graph. So the amplitude is easy to read off. It does start with that -3, but amplitude is always positive, so that'll be 3. Period and phase shift are a little different because that is not set up for just easily reading it off. However, our vertical shift we can read directly off. So let's just isolate this portion for our period and phase shift. So cosine of 4x minus pi halves. We need to factor out this 4, but still stay inside the cosine. So if we factor out the 4, that'll be x minus pi over 8. That's good because now we have the phase shift of pi over 8. But then we need to remember the formula that b is equal to 2 pi divided by our period. So our period is equal to 2 pi divided by our b. So that means our period will be 2 pi divided by 4 equal to pi over 2. For the function f of x equal to -4 tangent of pi halves x plus 1, find each of the following. So the period. So remember, for the tangent function, that value in there is the period of a tangent function is pi. So rather than 2 pi divided by that b value, it'll just be pi divided by that b value, which is pi divided by 2, which is equal to 2. So the period is 2 units. The vertical stretch / compression factor, we can see that that's right here with the 4. So we will have a stretch of 4. Does it reflect about the x-axis? Yes. We can see that in the negative sign. All right, shift up, down, left, or right. So the up, down, it's up by 1. No, left, right, shift. And now find 4 asymptotes of this graph. So asymptotes are when the tangent is undefined, and the tangent is undefined when we get tan of pi halves plus n pi, where n is a integer. Basically all that's saying is, tan of pi halves is undefined, tan of, if we added pi, 3 pi halves, tan of 5 pi halves. So that's all in the positive direction. It also works in the negative direction, so we could also say, dot, dot, dot here. Negative pi halves, tan of negative 3 pi, all the way on to infinity. We are asked to identify 4 of these asymptotes. So what values of x gives us these values? So we could say that x is equal to 1, 3, 5, 7. That would give us that, but it doesn't really help us graph the function. So we might also consider x at -1, -3, and also probably -5 as well too. Then we have this nice little graph here. So I'll just do, that'll be our -1, 1, 2. That's really small. Actually, now that I look at it, that should be a fine thing. So this will be our -1. +1, so this would be 2. And then our next asymptote at 3. Then right here at the edge of 5. So at -3, also at -5. We flipped it and we've had a nice stretch. So we should go through something along these points right here. and then at pi force, something like this direction. Oop. Just don't laugh at me for my bad tan lines. That's a joke. Alright, the tangent function shown here passes through the points negative 2 pi 7, 0, 5, and 2 pi 3 with asymptotes at 4 pi and x equals negative 4 pi. Find a tan bx plus k, so no horizontal shifts, plus the graph reflects that anyway. So show all work for B, finding B. I think finding B will probably help us in the long run here anyway. So we know from horizontal asymptote to horizontal asymptote, or vertical asymptote to vertical asymptote, is 1 period. And then the relationship that tangent has with its period is B is equal to pi over its period. This period, or the period in this case, will be 8 pi. Simplify down to 1/8. So now we know that. We also know this 0.05, that seems like it would give us some good information. So when we plug that in, we get 5 is equal to, we still don't know the amplitude yet, tangent of 1/8 times 0 plus our k value. Well, that means it's tan of 0, tan of 0, 0. So they get 5 is equal to k. Now for our amplitude, I'm just going to take this next point. So 3 is equal to our amplitude, which we still don't know, tangent of 1/8. Our value there will be 2 pi plus 5. So we can subtract off 5 from both sides, get negative 2, a tan, and then we can simplify this, 2 pi over 4. This is a special angle of tangent where it equals positive 1. So we get negative 2 is equal to our a. And then we can double check ourselves by plugging that all in and seeing if we get 7. So we should get 7 is equal to negative 2 tan of 1/8 negative 2 pi plus 5. And if we put that on the calculator, we do in fact get 7 equals 7. For the graph f of x is equal to 3 tan pi over 8 times quantity x minus 2, close parentheses, find the period and phase shift for f. So that period will be pi over this pi over 8, so it should equal 8 for our period. And then our shift is of 2 to the right. Two units to the right. Cool. Name any two vertical asymptotes for f in the interval -10 to 10. So we get a vertical asymptote when we get inside the argument, we get pi halves plus n pi. So one of the ways to do that is if n was -1, so we get a tan of negative pi halves. That would be undefined. We can look at that and see that at -2, that should occur. And then by the time we get positive pi over 2, that x would need to be 6, because 6 minus 2 is 4. Pi eighths times 4 is pi halves. So 1, 2, 3, 5, 6. There's that 2 point. Nope, wrong way. Just drawing the lines here. Yep. So x equals -2 and x equals, it would be positive 6. Find the period for each of the following. F of x equal to 6 tan. Let's get this previous stuff out of here. There we go. So, sorry. 6 tan, so we're going to look in here. It is set up for that. Remember that the tangent function, our period is going to be pi over that 1 over 8. So this is going to be equal to 8 pi. The cosecant has a period of 2 pi. And we see that we are properly set up for this to be our b value. So our period is equal to 2 pi divided by 2/3, which should equal 3 pi. So the period of this will be 3 pi. So name 2 vertical asymptotes of the graph. Y equals -2 secant of pi over 6x. So no horizontal shifting. And then also secant of x is undefined when x equals pi halves plus n pi. This is because the secant is also defined as 1 over cosine of x, and cosine is 0 when x is, pi halves, 3 pi halves, negative pi halves, all of those values of x. So then you would get a 1 divided by 0, which is undefined. So we're trying to name 2 vertical asymptotes of this. So I'm going to say we want secant of pi halves and secant of negative pi halves. So whatever x values gets us there. In this case, x equals -3 will get us a secant of negative pi halves, which is undefined, and x is equal to positive 3. We'll also do the same thing. And then any addition of, or add or subtract 6 from either of those values, and you would get additional asymptotes of that particular secant function. Good luck on your exam.